cloud architecture is not so different, right, from what you have when you architect your application, either on-prem, right, or on your own data center, right? The only major difference is that you don't manage this infrastructure. You have those responsibility taken away from you and being managed by someone else. And in turn, right, you got to also save a lot of money in terms of operational costs and all of that, or capital expenditure, right? Which is the other advantage that cloud solutions sort of bring to the table. But when it comes to architecting, solution and platforms on the cloud, right, there are a lot of nuances and a lot of things that you need to factor into your system design and your system architecture, right? You have various principles, you need to consider, and then there are a lot of requirements. For me, cloud architecture is about being able to bring the best out of your non-functional requirement, right? Being able to architect a solution for your organization, for your business, right? In an environment where you don't, have the God level permission to provision resources, and then, being able to serve your business efficiently and effortlessly, right? Things like high availability, fault tolerance, scalability, load balancing, disaster recovery, data replication, and then redundancy, right? Backup and restore of your data. And then you have things like automation with IAC, observability, and then monitoring of your entire platform. Things like, distributed and decoupled architecture, right? And API and service management, and also network reliance and, security and compliance. And then you have automated CI/CD integration and pipelines, and then approaches like self-healing system, and then multi-cloud and hybrid strategies being adopted, and service and database sharding, right? And caching for resilience, and then you do a lot of chaos engineering, when you are building a resilient cloud architecture, and you have things like versioning, and then roll back or roll forward strategies, right? These are some of the things that I want us to have at the back of our mind. Each one of those things that I mentioned sort of have like a high level, a very detailed approach as to how you implement all of those things when you're architecting on the cloud. When you are building a cloud, a fault-tolerant cloud system, right? There are certain things you have to consider, okay, to make your system, right, to continue to function in the event of, a failure, right, or a disaster, right, which is the bane of, this entire conversation. How do you make your business, your platform, right, resilient to failures and all of that? Some of the principles you need to consider, right? I mentioned some of them earlier, but I'll list a couple of them out. Things like redundancy, decoupling, over or fail back or fail over or fail forward, depending on the strategy that you've decided to do or to use, right? And then you have, things like self-healing, and then, graceful degradation of services or applications, right? Amongst these principles, right, I would just want to pick each one of them and then sort of like explain a bit further. So when you talk about things like redundancy, right, some of the things you do on the cloud, right, is you want to break apart your application. After the time when you deploy your system on the cloud, right, you have several components that makes up your entire application or your entire platform, right? And sometimes you have some of these components that are key, that they are part of your key infrastructure, your key application, right? So what do you do in that case? If, say, for example, you have a backend service that, is part of your core application that all of your other services are dependent on, right? What do you do when that particular application fails and then refuses to come back up, right? What you do in that case is you have, redundant you create redundancy around the architecture. You have service redundancy. You have multiple of those services running, right? Such that when one fails or one of these services goes down, right? You can take advantage of the other services that are still running, right? And then keep on providing services and serving your customers. This does not just mean your API service or your application service, right? It's also cut across, your databases and all of that. And then you have these particular applications and the databases running in multiple regions and then multiple zones, right? On the cloud, you have what we call regions and zone, right? Regions are geographic locations, right? Physical locations where your cloud providers have decided to put their data center. And in each of those regions, you have different availability zone. Part of the requirement to be a cloud provider, especially for the big players, right? They usually have like 3 data centers in one region, meaning you have 3 availability zone, right? On top of those 3 availability zones, you can deploy your application, right, across different data centers in that region, such that when there is a problem in one of those physical locations, right, your application, if you do replication, right, local replication, you could have your application spin up another instance. Say, for example, zone 1 goes down. You could spin up another instance immediately on zone 2, and then you keep on servicing your customer. Do not forget that the reason why you have, cloud, you are even provisioning your applications on the cloud, right, is to have a stable platform and to be able to serve your customers, right? Because the main reason for you as a tech person or as a cloud engineer or a software engineer or as a tech person is to serve the business, right? So if your application goes down, your platform goes down, then the business will definitely lose money and in turn possibly lose customers, right? So you have those things, and there are cases where you even have customers from multiple regions, from different parts of the world, right? You sort of provision your applications or your components, some of your key components of your platform in multiple locations, say for example, if you're a global platform, you have customers that are coming from Africa, you have customers in Europe, you have customers in Middle East, you have customers in the US or Americas, right? You don't want to deploy your application, say for example, just deploy your application in US, because this is something that I have seen over and over, where you have companies that have, global customers across the globe, but then they only provision their infrastructure in one specific region, half the time in the US and half the time in US East, right? US East across different cloud providers. The problem with that is that some of your customers will have degraded service, right? And then it's difficult if there's an issue or there's a problem in that particular data center, you won't be able to service some of your customers. And then even the experience that some of your customers they have based off of your, the physical location of where you decided to deploy your application, right? It doesn't help, the customer's experience. Now, what do you do in that instance, right? You deploy applications in multiple regions, right? And then so that you can service and serve, some of these your customers that are, distributed globally. The other component I would like to talk about is, or the principle rather, is the coupling, right? When you build applications on the cloud, you don't want to put, you want to leverage the power of the cloud in such a way that you are able to deploy your applications, decomponentize them, right? Decouple them such that you don't have tight coupling, right? This is something that most of us on this call, understand, right? You decouple your application in such a way that if one component goes down, right, it doesn't bring down the entire platform. I'd like to use a kind of microservice approach to sort of explain this, right? Just to simplify things, right? When you have, a lot of small services, that are distributed across different infrastructure, right? The advantage you sort of get is that when one of those services goes down, you still continue to serve your customer until that particular service comes back up, right? By breaking these things into different services, right? Say, for example, you have your authentication or onboarding service, right? And then you have, maybe your payment service and your notification service. You have, your core system, right? And then at that point in time, your onboarding service goes down, right? Your customers can still continue to perform, your already existing customers can still continue to perform, transactions or to continue to use your platform without having any problem. The only problem you have at that point is that you are unable to onboard, new customers. But in a case where you don't decouple things or you don't decouple your application into different, services or components, right? If, say, for example, one of your onboarding part of your application is affected, that tends to bring down your entire platform if you don't, decouple things properly. It's not just a matter of decoupling just your backend services, right? You also have to decouple things like your component, right? And then how you even deploy those things. For example, let's say your application, you use caching and then you use queue, and you decided to okay, you want to minimize cost, right? And you don't want to spend too much money using managed services, right? Because managed services can sometimes be very expensive. And you decide to okay, I'm going to dump my queue in RabbitMQ, my messages in RabbitMQ, and then dump use Redis, right, to cache my application. And during your design, you now decided to okay, I'm going to put those two components on the same server, right? The good part of that is that you tend to save money, right? But the downside to that is that if there is a high usage of resources on that particular box or that particular server, two of your components are going to be down, right? And at the end of the day, you will still get back to that approach that we discussed earlier, I mentioned earlier, right? Where if you don't decouple things, right? When one thing goes down, your entire platform goes down. So if, say, for example, you have high, throughput of messages coming in, you have a lot of inbounds coming in, and then RabbitMQ is using up a lot of your resources in terms of RAM and then CPU consumption, right? RabbitMQ keep on processing. Meanwhile, your Redis that you deploy box would suffer a lot, right? So that's why in most cases, when you are even, you want to even save costs and then go with deploying things on the VMs and all of that, it is still advisable for you to separate them. Separate the machine, that runs your caching system from your databases, from your queuing system, right? So that's the other thing. So it's not just a matter of separating backend services or things like. You also have to separate, your components, right, into their own logical system, and that's even in the case where you want to go the VM route and all of that. But ideally, in an ideal environment, right, you should be using cloud native technology like Kubernetes, containerized application and all of that. Now, the other principle is that you have failover and failback, right, or fail forward, like I used to say, right? When you set up automated processes such a way that you can switch to backups, right, of resources, or in the case of a primary failure of one of your components or your resource, right? So that way, when something fails, right, that we have a backup somewhere, right, that you can roll back to, because trust me, either you want it or not, right, things will definitely break in production. If you've been in ops before, half the time when software engineers, develop and all of that, they just do hand over to operational guys, right? Those guys are the ones that eventually suffers, and they know the pain points. They know some of where things are definitely going to fail, right? And then when those things do fail, you also have to have like a disaster recovery or business continuity plan in place, right? So these are some of the things that strategies that you'd use and principles that you must adhere to, right, to have a fault tolerant system, right? And then the other bit is self-healing, right? You need to enable self-healing mechanism, within your application, such that you design your system, right, your application in such a way that in the case of failure, your applications can automatically, self-heal or recover, right? There are different mechanisms that you can use to do some of these things. Things like, for example, automatic or automated, instance restarts, right? Or container rescheduling to say, okay, once this container is down or there's a problem with this particular container or this pod on this particular cluster, do a reschedule and then restart another pod, right? Bring up another pod such that that service does not go down for long. Or in the case where maybe there's high resource utilization on that particular pod that you've seen, you then spin up another one and then take down the old one, right? And then you also have, graceful degradation, right? This is also another pattern that you also, or principle, let me say, you should, adhere to, right? In a case of, a failure condition, you degrade your service, in such a way that you don't just shut down things, right? For example, let me use a situation where you have a streaming system, kind of, right? Something that streams maybe video or something. You have a service that streams, high quality video, but there is a service degradation. Maybe there is a low network connection at that point, right? Instead of still continuing to serve, that HD or 4K video, right? During that period, because there's a network degradation, at that point, instead of failing completely, right, you might want to serve an alternative low quality kind of video instead of failing altogether, right? So these are some of the approaches that you sort of like adhere to, and then these are the principles that when you build cloud systems, right, some of the things that you need to factor in. But I would also like to say that there is no silver bullet, right, to designing fault tolerant cloud system, right? There are things that you do based off of the environment, right? You find yourself, right? And then the kind of business that you are trying to operate. So a lot of factors you will have to factor, a lot of things you have to factor in into this, it's going to be, you do things that is going to be based off of what your business requires, right? And what your customers need. Okay, so in summary, right? That's those are some of the principles that you have to consider when designing a fault tolerant cloud system. When you want to approach disaster recovery, like I mentioned earlier, right? The bane of your existence as a cloud architect or a cloud engineer or even a software engineer, right, is to ensure that you serve your business and you serve your customer. You serve, you have this business continuity, in place, irrespective of what happens, right? We must continue to operate, right? And have the time. People in operations are the ones that really understand, the importance of having, a business continuity plan or disaster recovery plan in place, right? The way you approach some of these things, right, is it's not so simple, and then it's not also so difficult, right? Disaster recovery in the cloud is structured, it's a structured approach, right? For data, the very first thing you want to make sure that you don't lose is your data, right? And then there are a couple of steps or a couple of principles that you need to factor in, right, before you can ensure you have, a proper disaster recovery plan in place, right? There are two key things that I would like to mention here, right? You have your RTO, right? Recovery time objective and recovery point objective. All of these are part of, your disaster recovery, right? And I will just, sort of do a bit of explanation on those two things that I mentioned. The time objective is how long, right? Is your business or is your platform business-wise, how long is your platform allowed to be down? Okay. And then recovery point objective is how much data are you allowed to lose, right? In the case of a disaster. Disasters can happen. This could be a natural disaster. Say, for example, a bomb goes off somewhere near your data center, right? Which we don't pray for anyway. Or there is flooding somewhere, and then the entire data centers, is flooded where your application is hosted, right? What do you do then in that instance, right? So some of the things that you want to do, right, is to have, constant data backup and archiving as part of your disaster recovery plan, right? Some of those things that you have in a plan, data backup, you don't want to, say for example, let me give you an instance. A platform like Facebook or any other kind of essential service platform like a bank or an hospital, right? You don't want to lose that kind of data, right? For example, there's a problem in one of the data centers, right? And then you kept all of your data in that same region, that same location. If something goes to shit or something goes bad, right? You lose that data if you don't have a backup. And then because without data, right, your business is useless, your platform is useless, right? So you need to have, as part of your recovery plan, you need to be able to do constant, data backup, right? Service replication across multiple regions, and then you have the failover strategies in place, right? And like I mentioned earlier, you need to have, your services deployed, right, in multiple locations. Now, as part of, this recovery plan, right, you could run two regions. Say, for example, you operate out of Nigeria, and then your data is located in South Africa, right? South Africa could have like two regions, depending on the cloud provider that you are dealing with. And then you have your primary in one region, let's say maybe Pretoria in South Africa, right? And then probably your cloud provider has another region in Cape Town, right? You could do that and then keep, a replica of your database, your services in Cape Town. Primary is in, say for example, Pretoria, right? So let's say something happens in Pretoria and then your platform is unreachable, right? You quickly bring up and spin up, your resources that you already have, right? In Cape Town, and then you keep on serving your customer till that platform or that services, those region in Pretoria comes back up, right? Now, how often should you even do this, right? Say for example, data backup, and then how do you even handle, the two regions that you have? Should you run them in active mode? Because there are two modes, you can sort of, there are different strategies to this, right? You have, active mode and then active passive. To save cost, you could run the other one in passive mode and then run the primary one in active mode, right? The other thing you can do is run active if your business does not care about the money, right? And then, they are willing to spend that money because they are an essential service provider, right? So you want to make sure that you are in active mode so that when this guy goes down, you have a service that you can flip traffic from Pretoria to Cape Town, or you can flip traffic from your primary location to your secondary location. That way, your customers or your users will not even, notice that there was a downtime, right? So those are some of the approaches you have, run these things in multiple regions, right? Now, the other thing is you need to do automated testing, right? Because how do you even know that your platform is failing, right? Do you wait till customer starts calling you, or do you wait till customer starts, initiating that, oh, I cannot use this particular service, your platform is down? You don't do that, right? You have automated testing, even in production. And some of the things you can do, some of the easiest things you can do is you have, health checks endpoint that you can probe. You can have automated systems. Say, for example, you could have an health check endpoint on some of these cloud providers. They provide, monitoring capabilities, right? That you can use. On Azure, you have something like Azure Monitor, App Insights, right? That you can continue to use to monitor your application, right? And at that point, you don't just monitor the endpoints of your application, right? You also monitor the components that application depends on. Okay. So when something fails, it might not even be that your application is the one that fails, right? It could be a component that your application is dependent on that fails, right? You want to be notified before your customers even, notices, and then you go in either you have an automated way to fix that thing, or you have somebody come on, online immediately and fix that problem, right? You have constant automated testing, and then you have disaster recovery drills. This is part of, some of these things that we call chaos drills in chaos engineering, right? There are strategies that you have where you simulate disaster scenarios, right? And then you automate some of your disaster recovery drills to ensure that that system and process that you said you've put in place, right, can be activated as smoothly as possible in the case that a disaster happens. Okay, so these are some of the things that you need to some of the approach that you can take to ensure you have a disaster recovery in a cloud environment. One of the things that most of us don't even like to admit to, which there is no way you cannot even escape from it, is cost, right? Because businesses want to pay less, for the best, right? And then say for example, you deploy an application on the platform and all of that on the cloud, and at the end of the month, you tell your chief finance officer that, oh, we've spent $300,000 on the cloud. Meanwhile, the sales that your platform, the entire company built through that platform for the month, right? It's just 150,000, which is like half of the cost. Then you are going to have a problem, a very big problem, right? CEOs and CFOs are going to be on your neck. Not just as the architect, but also sometimes it could be the CTO who is responsible for that. Now, the trade-offs you want to sort of like take into consideration to make sure that you still have a resilient or a reliable platform, right? Some of the trade-offs includes redundancy, right? Versus costs, right? We all know that the more redundancies you have, the higher the cost. Like I mentioned earlier, right? Running deploying your components in multiple regions, right, would cost money. Okay, multi-regional application will cost a lot of money. For example, additional backup nodes or additional backup databases somewhere, right, just to increase fault tolerance, right, would incur significant additional costs. Okay, these are some of the trade-offs. Now, how do we even balance some of these things, right? For example, you could do cold versus hot, right? Instead of running two hot kind of databases or backup storage, right? You could run one in cold or even in archive mode, right? And run one in hot, right? So these are some of the things that you would have to do. The only downside to some of these things is that when you make sure that, okay, say for example, in a case where for the DR or disaster recovery part of your system, right, of your architecture, you've provisioned a lesser infrastructure in those regions, right? That way you could bring down the costs, okay? The cost of having, that resiliency in your architecture. I'll give you an instance. Let's say you're on Azure, for example, right? And then the data you have in your primary region, you have a storage account, for example, that's part of your day-to-day activity on your platform. Customers upload, images, they upload files, they upload different kind of, unstructured documents and all of that. You keep on backing up those things, right? But you don't want to lose those files, right? In the case of a disaster, and then what you can do is for your backup, where you back up those data, right, in your secondary region, you could have that one running as a cold tier or an archive mode. What that means is that you keep on, as your data keeps on coming in, right, you back them up in the other, account in the other region. But then at that point, that storage account is not running, with the same service tier or premium tier that you have in your primary region. That way you can bring down the cost significantly. Instead of paying like 2 times the cost of running your primary, you could eventually end up with 1.2 or 1.5% or 2% increase. 0.2 or 0.5% increase in your secondary region, right? And then the other thing you also want to do is, kind of service tier you have, right? When you have, redundancies and all of that in place, right? In your primary region, you could run premium services because that is your current production, right? And then in your secondary region, you have your applications deployed on those components or database deployed in that other region, but you are not using premium service tires in those regions, right? You're using something, lesser, okay? For example, you have something that is less critical in that second region. The only downside to that one is when there is a disaster, right, or something happens to your primary region, to take a bit, of time before those services can come up, or even if it doesn't take them time to come up, right, because they are in the cloud, they are always running half the time, right? The only downside is that they would not have, the same efficiency, the same performance throughput like the one you have, which is a premium service in your production, okay? And then at that point, you are still able to serve your customer, okay? But just not just with, the same capability as you would do in your primary region, right? So those are some of the, uh, trade-offs you would have to look into. And then the other thing you have to also look into is like auto scaling, right? You need to be able to automatically scale, either scale up or scale out, right? Either you do horizontal scaling or vertical scaling, right? For resiliency, in order for you to be efficient, right? But this can become costly in the case of traffic surge. I'll give you an instance where which would take me to a point that I want to make next, which is observability and monitoring, and then security consideration, right? When you are considering all of these things, right? And when you have auto scaling enabled on your platform, a denial of service or the DDoS denial of service attack, right, can cost your business money, okay? Not just costing you money because they are denying your actual real customers, access to your platform, right? But if you have an auto scaling in place and you don't have the proper strategy and the proper approach, right, to deal with some of those things, let's say, for example, you have one application that is able to serve 100,000 requests per second or per minute, right? And then one very bad actor decided to like, okay, I want to take your platform for a ride, okay? And then they start bombarding your platform with 1 million requests per minute. Don't forget, your platform can handle 100K per minute, and then they bombarded you with 100 million requests per minute, right? What that means is that if you have auto scaling in place, based off of that metric that you are getting, right, your platform, you would want to scale out, 9 more instances to make it 10 to accommodate that particular traffic, right? And then process that request. And eventually you keep on monitoring. And when that traffic, that load goes down, you then you scaling, you ensure that you have elasticity. The problem with that is that if you don't have, security mechanism and all of that in place, so say things like, for example, you monitor IP addresses before, load balancers and all of that in place to monitor those things before, pushing traffic to your applications, right? It will eventually cost you money. Two things: your customers don't have access to your platform at that point, right? And then you are scaling up resources, and then creating more instances and more expenses. At the end of the day, you waste money because you don't have the right security approach to deal with that kind of denial of service attack, and then your customers are being denied because they cannot use your platform, and then your business is not making money and you are spending money, right? Now, how do you even arrive at being able to properly scale and also to defend against some of these things, right? You need to have an observable platform, not just monitoring. Half the time we've seen platforms where people do monitoring, right, but they don't observe their platform. There is a slight difference between observability and monitoring, right? Monitoring is part of observability, right? But then can take it a step further, where monitoring, the way I like to look at monitoring is that you are being reactive, okay? Based off of the metrics you collect, the logs and all of that, you are reacting to that thing. And monitoring is reacting to knowns unknowns, right? But then when you are in production, right, there are unknowns, okay? Things that you don't even know that would happen with your system. You don't even know how users are going to eventually use your application, right? You need to be able to, respond to those kind of unknowns, and then be able to bring, your service back up and have, multiple instances and all of that. But there are different approaches as to how you achieve all of these things, right? You need to have automated testing. You need to, like I said, you have to constantly test your system in production. You collect logs, you collect metrics, you collect telemetry data for you to know, okay, how is my platform behaving? Do I need to scale out? And then you also look at things like, okay, how many error messages am I getting? How many 500 or how many 400 errors am I getting? Where are those errors coming from? Are they coming from a region where I don't have customers, actual customers, from my system, right? Say, for example, you serve customers in Nigeria, and then all of a sudden you get 1 million requests from China. What is going on, right? That kind of request, right? You want to throttle them. You don't want to process them. So eventually, hit your backend service and then, cause you denial of services, right? These are some of the strategies that you would have to put in place, right? And then eventually, you know, ensure that you don't spend too much money for nothing, right? And also to make sure that you don't just scale out, costing you a lot of money, and then you don't spend too less, denying you that resiliency that your platform needs. If you've operated in prod, right? Or you've been in operations, some of the challenges you have, right, is having consistent and repeatable environment, right? Or let me even say environment that you can just yank off and yank in another one, right? Those are some of the challenges you have. Now, how does IAC enhance system resiliency? It does that in different ways, right? The problem that IAC is meant to solve, right, is quite simple. You want to have your entire infrastructure that we used to provision back in the days where you have to do everything through clicking, right? In this case, you don't want to do that. You want to automate all of those things. Have your entire infrastructure in code, right? And then have the state of your infrastructure stored in a storage somewhere to say, okay, this is the current state of our infrastructure, right? Let's say something goes bad in production, and then somebody touched your system, somebody adjusted something or whatever, right? You can easily bring it back up, right? It's just like the same way it's easier for you to say, oh, this application, new version that you deployed is causing a bug in production, and then it's not serving the customer as well, right? IAC can help you do the same thing. You can say, okay, this particular infrastructure is somebody has made changes. We don't even know who did that change and all of that, right? You want to run your infrastructure code. It could be Terraform, it could be Pulumi, it could be whatever, right? Or Azure Bicep, or whatever, or AWS CloudFormation. Okay. To bring back the platform back to the state, the previous state that you had stored in a storage somewhere. It's like taking the state of our platform. So, okay, when we went live, we are using three EC2 instances, 3 Azure functions or 10 storage accounts in production. All of a sudden, you notice service degradation because somebody decided like, oh, this storage account is not being used now, and then they went ahead and delete, 2 or 3 of those storage accounts, right? And it degraded your service. What you want to do is to quickly go back to your, say, for example, your Terraform code and rerun that same script to bring back the service to the state where it's supposed to be, right? What that ensures is that you have consistency, right? You have rapid recovery, okay? And then you have version control of your physical infrastructure, right? And then you have opportunity to be able to do a rollback, right? Because you can track your changes, okay? You can even do a rollback in case of instability or failure. And then you have automated testing, right? Because your ISC codes that you've written, that Terraform, whatever, right? You can validate them. They can be tested. They can just like you test against your codes, your application codes, and all of that, right? And then you can catch those configuration errors before they even make it to production, right? Before deployments, okay? Which sort of like increases your reliability, all right? And then at that point, you can also have like, it also helps with scalability as well. That being said, ISC makes, some of these things easy to automate, right? And then help your system response, to respond to metrics dynamically, right? So that you can, scale out to handle your load changes. Okay, some of these that I've mentioned to have high availability, okay. Multi-region or multi-availability zone is something that you don't joke with, right? This will help you to avoid, single points of failure, right? Like I said, deploy your application in multiple regions. If you, depending on, where your customers are present, right? And where your cloud provider has a data center, right? Leverage those multiple availability zones. Truth of the matter is it might cost you more money, right? But don't forget that the more stable your platform is, right, the more money you are able to make from your customers. Okay. So you want to leverage, availability zones and then multiple regions to avoid single points of failure, right? You want to leverage things like constant health monitoring, and then you have automated recovery, health checks, automated recovery mechanism to detect and replace, unhealthy resources or instances of your ports or your application running, right? You want to have all of those things. And the other thing is try to use managed services as much as you can. Okay. One of the advantages of using managed services is that majority of these resources on the cloud, these managed services are usually highly available and they are fault tolerant. And then it sort of gives you that rest of mind where you don't have to do any kind of managerial work or maintenance activity on those services, because you are not even managing the physical infrastructure at that point. You don't have anything to worry about. Let the cloud provider, they are getting paid for it. Let them carry that headache, right? The other thing you can also do is you have to load balance your application, right? For you to have effective, load balancing, to effective, multi-region deployment, right? You need to have a load balancer, right? Which is the first thing that your customers' request would hit, right? And then I mentioned something earlier, right? That you don't want a situation where you have a lot of requests coming in, okay? And then those requests are not valid requests, right? You could do that at the load balancing level, whereby before you even forward those requests, okay, to your backend service that will process those requests and then start denying users access, right? You could inspect some of those requests that are, as they come in, right? And then say, oh, this one is not valid, yank it off, right? Some of these are not done just at the load balancing level. There are other components that you need to add to it and all of that, right? To be able to do all of these things, okay? So you can distribute your traffic. For example, if you have a global audience or customers across multiple regions, multiple continents, right? You need to provide provisional resources in those areas that are closer to your customers. And then you have one global load balancer, right? When your request comes in from any of your applications globally, they go through that load balancer. The load balancer look at the header of your request and then determines where the IP address is coming from. Somebody is coming from Nigeria, send them to the South Africa data center. Oh, this person is coming from Germany. Send them to the UK data center. It routes the request based off of the location of the instances that you have deployed on the cloud, right? And then they get routed to the closest instance of your application that is closer to them based off of their geo location data and all of that, right? And also you leverage things like auto scaling. These are things that you cannot joke with. Elasticity is very, very important when you build cloud applications. Okay, you have auto scaling policies in place to adjust resources, based on load, right? Which sort of prevents resource exhaustion. And then when that load, the traffic drops, you scale down as well, you scale in as well. That way you don't waste money. And at the end of the day, you balance both. I have a couple of examples in my head, but there is this platform that I worked on a couple of years ago. They are like Airbnb, right? I'm looking for the term that we call that kind of business. So you have customers coming from various locations, right, globally, where you want to rent out your apartment, or you want to rent. No, it's not even just an apartment that these guys do. You need vacation homes, right? Say for example, you are going to East Germany or something, or you are going to Belgium, and then you need a vacation home for you and your family, right? And you are coming from Nigeria. You need a place to food to your family and all of that. So we built a platform like that. Now, what did we do on that platform, right? Some of the things we did, right, to ensure that, and because this is a platform that we had a lot of high transactions coming in, a lot of requests comes onto the platform, a lot of users visit that platform, and then you have a lot of data that we have to display. We had images, we had videos, we had customer reviews, video customer reviews, and all of that, right? That you have to display on the platform. Now, how do you ensure that all our customers globally, they get the same the same experience, irrespective of where they are coming from or where they are visiting from, right? Or where the house owners or the vacation home owners, irrespective of where they are located, right? They also get the same experience, right? We had to do things like multi-region active setup, right? Which costs the business a couple of money, a certain percentage more money, right? But then it gave us, that platform to offer our customers, right? That kind of experience, that user experience that they were not expecting, right? And then we did, database replication, right? Globally, we in different regions, and I mean, for our database, they were like placed strategically, right? It's not like we did, across the globe everywhere, but we placed them strategically based off of where we have applications deployed. The regions we have applications deployed, sort of deployed database closer to them, and then we have things like called replicas. We sort of help us, handle every workloads, right? And then we use a lot of caching. A lot of caching was done on that platform. We cache a lot of things. Not all of your requests that is coming into our platform gets, pushed to the database to fetch that data. We'll send you whatever data we have in cache, right? And then we use a lot of CDN. There are some static data that we don't go into our storage account every time to pull them out, or S3 bucket, whatever you use in your own case, right? To pull them out and then send to you. We use CDNs and place them globally. That way, those resources are cached because they are closer to you, and then you get access to them. And at the end, during all of this, right, we had all of our application containerized because you don't want to do a situation where when we need to scale out, right, you now start thinking of, oh, I need to deploy this application on another virtual machine, right? We didn't do that. We use containers, okay? And then we are able to automatically say, okay, we had, high availability configuration on our platform such that when traffic comes in, scale up 2 more, 3 more pods on those Kubernetes clusters that are deployed globally, right? Say, oh, traffic is coming through this particular cluster, and a lot of users are coming there, and we only have like maybe say 4 instances of that particular pod running. Scale it out to to 8 pods so that we can handle that request at that point. And then when it goes down, scale back in, right? And then the last thing we were working on before I actually left that project was, engineering chaos into our own system, right? To have, to perform controlled experiments within our system, which was the last phase of that implementation that, we were working on before I eventually left. But it was something that we started, but I wasn't part of the team to eventually finalize it, right? So these are all of the things that we did, right? And then the platform up to today, when I still check, I still say that, oh, it's still, going strong. I know a lot of these would have been made, right? But then these are some of the things that, we did. Okay, IoT is one sector. Don't let me call it an industry anyway. That is quite interesting, right? And then if you love engineering, you will love working on IoT projects, right? Some years ago, I worked on IoT project where I had cold chain solutions globally, that could run globally, and then that device sent data every, I think, was it 30 or 50 seconds, right? We collect data from that device. We collect, environmental data like humidity, temperature, and all of that. And then the system will now use that data that it's collected because of where that device is located, right? To now send additional data back to that device, okay, to regulate the fridge inside that particular device, right? That way it can automatically, and then you can, if you have an admin monitoring that particular device at that point, you could adjust the temperature of that particular, depending on what that device is housing at that point. And also, during that implementation as well, you collect not just that data I've mentioned, you also collect geolocation data to know the location of that particular device at the at each particular point. We collect a massive. That's where you if we send that kind of data, right? Every it's not even I said 30 seconds, every second, right? So our backend said that's there, the huge amount of data we were collecting, from those places. Now, this brings me back to your question, right? How do they impact resilience in, resilient cloud infrastructure, right? This is, like I said, it's a different challenge, right? Because these applications are decentralized, and then you have high frequency of nature of device interactions, right? Both from the device and then to the device as well. So, some of the things that you know you would notice and then you witness that you need to adopt things like edge computing, right? You process data, right, that are closer to where those devices are located, right, with edge infrastructure. This will reduce things like dependency on your central cloud services or central cloud infrastructure, right? This way you can have better resiliency and allow for local functionality within that region or that location, right? If in a case where you have your central cloud infrastructure is unreachable, right? You have those edge system or computing deployed closer to them, and then you have things like real-time data processing and all of that, right? You have to be able to process those data in real time, right? Now, how do you handle, a high throughput of data? You use things like message queues, you break your system into an event-driven architecture, and you have distributed databases. Those are some of the things that you have to do, right? To combat that kind of challenge. And then you scale your IoT data, right, in such a way that you position your databases, okay, irrespective of the kind of database you are using, right, to make sure that you handle high data ingestion, right, without bottlenecking. That's to say use managed services. That's not to say that's the only way, but making use of managed service makes it easier for you to scale and all of that, and then it removes a lot of operational maintenance stuff from your head, right? And then there are things like device and network resilience and all of that, right? When you develop some of these applications, right, your application needs to be able to handle network disruption. Your IoT application that is running on your, this is not just about the kind of application I mentioned earlier. It could be your POS machine if you're in finance, right? Half the time, your POS machine would lose network. Okay, how do you now make sure that the customer transaction that they are trying to do at that point, right, does not outrightly just fail or whatever, right? You need to also ensure that you have offline data storage to ensure that continuous operation, right? Even when there's intermittent connectivity disruption and all of that, right? So these are some of the things that you do to combat those challenges. And then it brings me back to security and privacy, right? Because those devices are not part of your physical network or your virtual environment that you can secure with a firewall or something, right? You need to make sure that you apply end-to-end encryption. So both encryption on that device and then on your end as well. End-to-end encryption has to be, you need to have things like secure authentication. You need to be able to do data anonymization, right? To sort of prevent in a case where there is a data breach. Maybe somebody stole one of your IoT devices, right? When they steal that device, they shouldn't be able to make sense of the data on that device, right? You should do encryption of those data on that device, right? And you can have different requirements for compliance, right? For different compliance reasons, okay? So these are things that you need to factor in. Security, and I would like to say that all of the questions that I've answered earlier, right? Most of these are that, things that you do that are security compliant. Security is not something that you put like as an afterthought. No, it has to be at the forefront of your design, okay, from day one, So you need to make sure that the way your application, your IoT devices are, designed, right? You make sure that if somebody gets hold of that device, maybe they stole it or something, right? They will not be able to make sense of that data. There are different approaches as to how you can do that. You could have, an encryption key on the device, to encrypt that data, and then when it gets into your system, you decrypt that data, at your hand, and then you do encryption in transit, and then encryption, at rest, right? Encryption at rest is you encrypt that data when they are on that device, and then when they make it to your database, right? And when they leave that device and they make it to, when they leave that device, while they are moving through the network, they are also encrypted. Okay, you do end-to-end encryption, and sometimes you deploy things like virtual private network and all of that to make the connectivity between your IoT devices and your edge computing into your actual centralized data cloud environment. You make them a lot secure and private. To answer your question objectively, right? Anybody that knows me knows that I'm a Microsoft fanboy, right? I am an Azure person, but you don't choose cloud provider because of your own preference. There are different things that you have to consider, right? One of them is okay, so let me take a step back, right? Sometimes when you're selecting a cloud provider, okay, you are selecting cloud providers based off of the partnership or agreement, right, that your business, okay, has with that partner, that cloud provider, okay. But I've been in cases where business owner will tell you, we are going with AWS, and there's nothing you can do, right? Because they are getting a cheaper offer from AWS that they are getting from GCP, Oracle, or Azure, right? And I've seen cases where they will tell you, no, we are not going with AWS or Azure or GCP, we are going with Oracle, right? Because of a couple of things. Oracle is the only one that has a physical, that has a physical location in their country, and then they have compliance. They have regulatory that they have to comply to, right? For example, if you are in fintech, they will tell you cannot move your data onto the cloud, especially your core banking data, right? Some of us might think that data is useless. What does it? Is it not just my transactional data? I don't care. I don't have money in that account now. You don't know what people can do with that, transactional data they have. They can know how you make your money, where you make your money from. They can deduce a lot of things about you based off of your financial data, your transactional data, right? And the same thing now, if you now look at medical kind of data and all of that, right? It tells a lot of stories. So back to your question, how do you choose the right cloud provider? Sometimes you won't have the right choice, but in a case where you have the choice to choose your cloud provider, a couple of things that I personally like to think of, right, is one, always factor at the back of your mind that you won't always, as the architect or as the engineer, the lead on that particular project, you won't always be on that project for life, okay? You also have to consider the ease of getting talent, right? Or getting additional talent after you left, after you've left, or after, what are the talent that are available, right, to sort of like manage and use the platform. That is one. The skill set is one. Two is that, like I said, on the business side, what are the partnerships that you can leverage on to save cost half the time, right? That your business can benefit from. If AWS is giving you a cheaper deal, for example, right? And you say, oh, because our application is built with .NET, I have to go with Azure, right? If your CEO or CFO gets hold of you, you're in soup. You have to come and justify as to why AWS is giving us 20% lesser deal, and you are saying you are going with Azure, right? You need to be able to make, there are ways to make, technical decisions, right? A lot of factors have to be, a lot of things have to be factored in before you make that decision. Sometimes it could also be that, oh, this particular service from this particular service provider, right, is way better than the implementation of this service provider, which you also have to factor in. Okay, there are cases. I'll give you an instance. Let's say you want to run ML models, right? I'm an Azure person. I would recommend you run it on Azure. Go to the AWS, right? Right, because you get cheaper this and all of that from there. And then there is this case where I was talking to a business in Saudi a couple of months ago, and then they are telling me they couldn't use other service provider, even though they are a Microsoft shop. Their end-to-end system is .NET, right? And then with a couple of Java applications here and there. But they had to stay on Oracle because of the compliance regulation that they had to adapt to, right? So these are some of the things that, would force your hand to say, okay, these are the provider I want to go with. You also always have to make a decision based off of what is best for the business, okay? How easy is it for me to get, for the business to get talent, right? You will look at your region. Oh, you would definitely know, say for example, in this particular region, we have a lot of, AWS cloud engineers or architects and all of that around, but we don't have a lot of GCP engineers. But it, GCP, you feel like, oh, I know GCP in and out. You don't choose GCP for them, right? You choose AWS that they can easily get, talent to manage, that particular infrastructure or that particular system, right? Your second question, I wouldn't want to answer that question, right? Which is, what is your favorite? I think I already did anyway. I love almost everything Microsoft and all of that, but then we do what is best for the business, right? We go with what is, what would work for the business, what would make the business, the business itself thrive. And then it's not about also what we want or what we like or what is our favorite, right? It's about what is best for the business, because whatever you do, you are here to serve the business and the business alone, right? The interest of the business. So you make that decision. A lot of these things you have to factor in, a lot of things. In fact, some compliance regulations would even deter you from provisioning your infrastructure on these three big brothers, Azure, AWS, GCP, right? They might even force you to use a local cloud provider, the one that is operating in your country. For example, you might be forced to use Google Host, right, in Nigeria because of compliance regulations and all of that. Because if you don't comply, at that point you feel like, oh, I'm getting cheaper deals on Azure now, and they're giving me cheaper deals than Google Host is giving me. No problem, go there, right? At the end of the day, when those compliance guys comes for your business, okay, that deal you thought you got from those other provider, right? You pay times 3 of that money to them for you, and then they will still eventually force you to comply. Okay. So, like I said, you need to make decisions based off of what is best for the business. There are a lot of things you have to consider, right? And it's also those things you consider will change, right? Especially when it comes to compliance and all of that, right? Based off of the region you find yourself, because there are different rules for different regions. Every decision you make, right, is to support the business, and then to also make sure that whatever decision you make, okay, as to having a multi-cloud strategy, right, is in the best interest of the business. Okay. Now, what are my own thoughts, right? I am not for or against it. That's one. Two is that some cases you have to operate as a multi-cloud operator, or as a multi-cloud provider or company. For example, because of regulation, right? Let's say there's a regulation that says, oh, your databases, they cannot be on a cloud environment somewhere, right? And then you have to provision your databases locally, either at your own physical data center, right? Locally, okay? And then, or use a cloud provider that operates within your country, right? And then all of your other components can live outside that particular data center which they don't care about anyway. Now, that being said, you could find yourself in a situation where what I just explained, right, is hybrid cloud strategy anyway. But in a case of multi-cloud strategy, right, you can find yourself, like I said, different things can force you to make that decision. And I find myself in cases where we have components, right? our Kubernetes cluster, we're running on AWS, right? We had EKS applications running, and then our databases were on-prem, right? And our front-end applications and all of that, some of the, models that run some of our machine learning applications and all of that are running on Azure, right? And then we had components also running on Google because we wanted to leverage Google's mapping capability, because nobody does mapping, geolocation more than Google, right? And we had an application that wanted to leverage on that. And then in that case, that sort of people, like in kind of people, you will be thinking Azure has, Bing and all of that map, right? But then when you look at it, let's be realistic. Google does it better than any other person, right? When it comes to, geolocation data and those mapping stuff, right? So you have to eventually deploy your applications, across those multiple cloud environment. But the problem is that you are going to spend a lot of money, because ensuring you have secure connectivity between those three different platform or multiple cloud providers, right, will cost you money. You also have to ensure, there is maybe a VPN tunneling somewhere that your application running across those platforms will use to connect securely, right? Because security is not something you think of as an afterthought, right? So a lot of things you have to factor in before you can say, okay, let's adopt multiple cloud environment. And there's a lot of use case scenarios where you find yourself that you have to do this. Okay. Resiliency is you being proactive, right? Make sure you balance cost and your need. Prioritize critical systems for redundancy while you optimize your cost for others, right? About resilience is being proactive, right? Design for failure, automate recovery, and then validate continuously. Okay. Leverage cloud native tools as much as possible. All right. Use managed services, leverage IAC, do continuous monitoring. Okay. To simplify, your resiliency and all of that. And then, for emerging technologies or emerging challenges like the IoT and all of that, right? Push, the need for distributed application or distributed infrastructure, right? Or components to make sure that you have, real-time resiliency, all right? So those are some of the things that I have to share. So my closing thoughts is this. My closing remark for you is plan for failure, build for resilience. Thank you.